Right troops, we're going to do our ring continuity test. Testing stage 1, little r1, little rn, little r2. Obviously prior to the test, make sure you've got yourself a low resistance ohmmeter, or in this case a multifunction tester that can test between 4 to 24 volts AC or DC, minimum short circuit current of 200 milliamps. Check to make sure that your meter's calibrated, general condition of your meter and your leads, and your battery condition. First thing that we're going to do is we are going to zero our leads. So with the crock clips, we're going bottom jaw to bottom jaw, make sure we've got a nice tight connection. Zeroing the leads, the wee zero comes up, and then we're going to test little r1, little rn and little r2. Now all of these loops are of a similar size, so I should be getting roughly the same reading all the way through. So 1.14, 1.11, and then here we are 1.14, so three similar results. Obviously from this point we can then work out what our expected readings are going to be on stage 2 and stage 3. Right folks, now that we've carried out our stage 1 test for our ring finding socket circuit, what we can do is we can then move on to stage 2 and stage 3. First and foremost, to check polarity of our socket circuits and to obtain our R1, R2 value. As well as that, we will also prove that there are no rings within a ring. Prior to moving on to that test, however, we need to know what we're going to get as a test result for stage 2 and stage 3, or what expected range we should be looking for, so that we can either identify any rings within a ring, any spurs from the socket circuit, or any actual faulty socket outlets themselves. Because bearing in mind, you need to remember that the sockets themselves have contact resistances, switch resistances, and it's not been the first time we've had a bad batch from a supplier which has given us far higher readings at the outlet than what we get at the back of the socket itself. Okay. If we were testing to the back of the socket, we would expect to get bang on our expected reading, probably not as high as 0.05 ohms of an additional resistance if we're testing to the back of the socket. Right. Stage 2 of the ring finding socket circuit test, we are going to be taking our adapter connected to our line and neutral leads and testing in to the line and neutral connection at each socket outlet as we work our way around the ring finding socket circuit. Okay, so we will take our adapters and we will pop them in to the actual socket outlet. Okay, as I said, we'll work our way around the circuit. The socket itself, as you can see here folks, this line probe is connected to the line conductor, the neutral probe is connected to the neutral conductor. Even visually, just looking at it, you can see here we have a shorter cable run back to the board as what we have around the rest of the installation. Now, prior to carrying out this test, we have to carry out a link at the board. Okay. Hopefully, you will have your conductors marked for you, a 1 and a 2, maybe a set with a piece of tape round about them, some sort of visual identification for what your incoming and outgoing leads are. Obviously, if it's twin and earth, it becomes easier to identify your ends for your ring, but we connect our incoming neutral with our outgoing line and vice versa on the other side. Okay, so even visually looking at this, on this line conductor here, we have a small resistance running back to this link, and then a larger resistance running back to this link here. Yeah? So we have a larger resistance running away, small resistance running back, and vice versa on the neutral side. If we look at where our cables are actually connected, if you look up here, you will see our short resistance on the neutral is connected to the long resistance on the line conductor, and vice versa on the other side. So what that will actually look like when we come to test is we will have our large resistance on one side, our small resistance on the other. And again, remember, on the neutral that reverses. So we have here next to our large resistance a small resistance, and next to our small resistance we have a larger resistance, and then here we have our link. Yeah, so this is the link here. Yeah, that's the links. Oh, that's the links there. Okay. As we work our way around this circuit, what happens here is this resistance here gets larger. This resistance here gets smaller. So there's our long resistance. As we move away, you'll see that we've increased the resistance of this conductor, we've decreased the resistance of this conductor, till we get to the midpoint. At the midpoint, both resistances should be roughly 50-50. And then as we work our way back, the resistances then flip, where we have a larger resistance on this side coming back with a smaller resistance moving towards the link. Okay. If you notice, the resistance on this side and the resistance on this side should be identical. Basic parallel circuits, if we have two resistances which are identical in parallel, we take one of the resistances and we divide it by 2. Yeah. Again, if we had 10 resistances that were identical in parallel, we would take one of the resistances and this time divide it by 10. Okay. So the maths for this, for what we should be expecting for our little r1 plus our little rn, our expected value should be little r1 plus little rn divided by 4. So r1 plus rn, 1.14 plus 1.11 equals 2.25 divided by 4 gives us 0.56 and change, 5625 ohms. Again, one of the things I said earlier is we have to take into account our expected contact resistance, switch resistances and things like that. So we have a range, yeah, of 0.56 to 0.61 ohms. That's taking into account 0.05 ohms additional resistance for contact resistance. For our R1 plus R2 result, all we're going to do is we are going to insert the R2 figures where we had the Rn figure. So our R1 plus R2 expected result is R1 plus R2, little r1 plus little r2 divided by 4, 1.14 plus 1.14, 2.28 divided by 4 gives us 0.57 ohms. 0.57 ohms. And again, our range that we should expect on stage 3, 0.57 to 0.62 ohms. Yeah, again taking into account that negligible impedance for the contact resistances. Obviously we're carrying this out between our line and neutral for stage 2 and our line and earth for stage 3. The one thing that remains constant through both of those tests is the line conductor. After we've carried out this test and our results are as expected, we can also tick, as well as recording R1 plus R2, whatever the highest figure is that we actually obtain at the socket circuit. We can also tick the polarity box. Yeah. Now, where might we have issues? We might have issues where a particular socket outlet is given as a high resistance contact. Yeah. Okay. The sockets that are on that board just now are from a particular manufacturer, and one of the sockets I've had to replace 3 or 4 times now, because one of the contacts on one side of the socket continually seems to be failing. Yeah, so that's something we have to be aware of. Some manufacturers, we do sometimes have issues with materials. Okay. But again, the overall resistance is not massively higher, but it's enough in this installation for it to show a measurable difference in our socket circuits. Other issues we might have, if we carry out our test and rather than getting our expected range between 0.56 and 0.61, we get a reading lower than 0.56, yeah? That tells us that up here, rather than connecting across the way, we've connected across both ends. So if you see here, we then have a small resistance connected to another small resistance. So we have 2 small resistances on one side, 2 large resistances on another, basic parallel circuits. If you have 2 parallel resistances, the one thing that you can guarantee is your overall resistance of the parallel circuit will be less than the lowest resistance. Okay, so what will happen there is we'll get a lower than expected result until we get to the midpoint where we get our expected result, and then as we work our way back, our results will then start to go lower as we move back towards where our incorrect links are. Another issue we might have a ring within a ring, and in a ring within a ring, what's happening here is we have a connection like so across our circuit. We might get our expected readings, yeah, up to this point, but the minute we jump into this ring within a ring, we then have a different layout of our parallel circuit. Therefore, we end up with readings lower than expected. And again, if there are multiple sockets across this ring that are attached or wired in between this ring within a ring, our readings will go up and down. Yeah, okay. So again, remember, end of stage 1, carry out your calculations for stage 2 and stage 3. Make sure you know what your expected readings are going to be. Make sure that you're taking into account our additional contact resistance. Any sockets that give you a higher than expected reading, further investigation is required. Yeah, okay, so we might find out that it might just be a duff socket. We might find out that we have a poor connection at the back of the socket, but our individual loop test should have proven that, and our visual inspection and check should have proven that as well. Or we might find that we've got a spur from the socket circuit, okay, which gives us some larger than expected readings. Obviously, if we were doing this in this instance, all our conductors are the same size. If it was a twin and earth installation, our CPC will generally be smaller than our live conductors. If it was a 2.5 and 1.5 system, if the individual loop values for the R1 and Rn was 1 ohm, then I would expect between my 2.5 to my 1.5, I would expect my 1.5 to give me 1.67 ohms there or thereabouts. Yeah, okay. And all we do is we just factor in those results into the calculations to make sure that the results that we get at the socket outlets are in fact what we should be obtaining. Okay, so hopefully that clears it up for you folks. Right folks, we're now moving on to stage 2 of the ring continuity test, where we're going to obtain our R1 plus Rn values. So we get 1.14 on our line and 1.11 on our neutral. So little r1, 1.14 ohms, little rn, 1.1 ohms. Our expected result, add those two together, 2.25, divided by 4, we're expecting to get roughly 0.56 plus 0.05 ohms, so anywhere between 0.56 up to 0.61 ohms at these socket outlets for stage 2. Obviously it's a 2-lead test. We're going to be testing it out at the sockets between our line and neutral connections. So on our plug top adapter, we're only going to be using the red and blue leads. So once we get the red and blue leads in, we are going to set it to low ohms again, and we are going to zero our leads out with our null adapter, £27 by the way. Make sure our leads are zeroed, and we're going to carry out this test at all the socket outlets. Prior to doing this, we need to link our incoming line conductor with our outgoing neutral. So we've got a conductor here marked with a 2 on it, so we'll get our wee croc clips in, and all these are just croc clips with about 6mm going between them, just to make sure that we've got a negligible impedance. And then likewise on the other side, again making sure that we don't come in contact between our adapters. So again, remember 0.56 to 0.61 is our expected readings here. And we're going to check it at each socket outlet. Slightly higher than what we were, look up, down to 0.6, okay. .6, again that's us back in the ballpark of where we're looking for. 0.6, again. 0.61. This one here is giving us a far higher reading. When we investigate later on, we will find out that this socket here is actually a spur from the ring final socket circuit. Okay, so that's why we're getting a higher reading. Back to the sockets that are actually on the ring. 0.58, again back in the ballpark. 0.58, again back in the ballpark. Make sure the plug's in, there you go, 0.60, back in the ballpark. Again, make sure it's in properly. Moving down into our ballpark of where we're looking for. Okay, so the sockets that were on the ring have given us our expected reading. This one here is obviously giving us a higher reading because that's a spur from the ring final socket circuit. So far everything is as expected. Right folks, we're moving on to stage 3 for the ring final socket circuit test. Again, low ohms. Previously we were testing between the line and neutral connections. This time we're going to be testing between the line and the CPC for our R1 plus R2 value. So we're going to swap out the neutral lead with our green lead. Hopefully our lead should still be nulled. So we'll put our null adapter in. Still nulled, it's not flashing telling us we've got a negative. I'm then going to swap out my neutral connection, so that's the number 1 connection. I'm going to swap it out with the number 1 cable on my CPC, and likewise for my number 2 neutral, I'm going to swap it out with the number 2 CPC, again making sure I've got good solid connections. Now the last time we got 1.14 on little r1, 1.14 on little r2. So our expected result should be 2.28 divided by 4, so roughly 0.57 there or thereabouts. Okay. Again, plus 0.05 ohms, which we should get at every socket outlet. Again, we need to remember this one here is actually a spur from the ring, so that will give us a higher reading, but we'll declare the winner every time we go. So 0.6, 0.6, 0.6, 0.64, just slightly above our ballpark. We were expecting roughly 0.62. Oh, there you go, it's slowly working its way down. We'll check to make sure we're getting a good connection. 0.61, we're back in the ballpark. Right, so 0.61 is our current winner. We're going to the spur from the ring final socket circuit. 1.06, 1.06, that's our highest reading. Therefore, as long as we don't get any higher reading, that's what we will record as our R1 plus R2, 0.58 there. 0.6, back in the ballpark again. Yep, working its way down. 0.61. So the highest reading that we obtained at our spur, that's the one that we're going to record as our R1 plus R2 value. Because we get readings at every single socket, yeah, the one pair of conductors that was consistent through our test was the line conductors. Therefore, as well as recording our R1, R2 value, we can also tick our polarity box as well. The R1, R2 value that we got here, we can then add to our ZE or ZS at dB for this installation to obtain the ZS for the circuit. Obviously, we check that against the appropriate table in BS 7671, table 41.3.